right, so this is 129S. Oh, Facebook went up today, eh? Good. Yep. Yeah, the devaluation for a while would take them actually out of the big monopoly class in some drafts of a bill, but they might just revise that bill anyway. All right, so here we are, and I'm going to talk about Chapter 4 and then demonstrate the first batch of Web Security Academy labs, which are very easy. And so let's jump into that. I should have the chapter here. All right. All right. So you map the application. This is one of the first steps you have to do when doing a pen test of an application or finding vulnerabilities. You have to find all the pages and all the transfers and everything. So there are spiders that will try to automatically click every link on a page and follow every link. And this is how you determine the attack surface, all the functions on the website, and therefore all the parameters that could possibly be used to attack it. So one way to do it is with a spider. A spider is an automated thing. This is what search engines use, like Google. They spider every site to find every page they can and index it. So it loads your page, finds the links, then clicks all the links, then finds more links, and goes on in that regard. That's the simplest kind of spider. Google does quite a bit more than that. They obviously also use a list of common words, because as many people can tell you, if you put a page on your site and you don't link to it, that will not stop Google from finding it. So now, if it was Web 1 and all you had was static pages with static links, then that kind of spider would work pretty well. But the problem is now we have a lot of forms. Like you might have to log in to see certain pages or answer some kind of question on a form to get in there. And simple spiders just try to fill the forms with random data and submit them, but that will usually not work. It will reject those forms for having something wrong in the zip code field or something. So there are tools that can do this, like Z-Attack Proxy is a free proxy, very much like Burp from OWASP, and it has the ability to spider websites. Another issue is robots.txt. The idea of a robots.txt file, here's City College's one, is you're supposed to be able to list a bunch of folder names on your site or files, and those files are not supposed to be indexed by search engines. So, of course, hackers will just see this as a direct pointer showing them where the goodies are, and there's no real enforcement to force a search engine not to look here. They're just not supposed to. So automatic spidering might fail to see pages because it can't get past navigation elements. Yeah, it's a big list that says do not touch, yeah. And so there's also links that are in compiled objects that it won't find in the source code of a site. So also, it may not be able to fill out forms correctly. Most spiders can't understand the questions, so they won't really fill out the form right. And they only fetch each URL once. But some pages use the same URL for many different kinds of content. And then it'll fetch one copy of that, and it won't realize that there's other content you can see with a URL that looks the same. So, the problem is the websites are too chaotic and complicated for most automatic spiders. And I must say, this came home to me maybe 8 years ago when I decided there was a big test of Android applications. And the CERT, Computer Emergency Response Team, found thousands of vulnerable Android applications and reported them. And I came by and tested some of them to see if they were still vulnerable, and they were. And then I tested a bunch of other apps, and they were vulnerable, and they had not been caught by their automatic process. For this reason, I think, because I did it manually, and I think I was able to test the apps more thoroughly than their automatic scanner. See, an old slang from China, hiding silver, and put a note on the ground that this place has no silver. Yeah, that's essentially what it is. Yeah, that's right. Yep. All right, so spiders aren't really smart enough to get in many types of pages. And here's another thing. You might have volatile data within the URL, like a timer, so that the same page has like a parameter that's different every time, so the spider will make many, many copies of that page, thinking it hasn't gotten them all, when it's just always the same page. And there's another thing. If you have parts if you have a login, then a bunch of the site will only be visible after you log in. So you might have to give the spider credentials or a cookie to get in, but if you do, the spider will try to click every button on a page, like log out and so on. And it will also request pages out of sequence, which a well-designed site might log you out for doing that, as you obviously are not a legitimate user. And another thing is they might find an administrative page and then click every link like delete database, restart the server, delete user. So you really don't want to be using an automatic spider that's logged in with administrative credentials. So the safer procedure, although less perfect, is to use user-directed spidering, where you do what I've done several times in demonstration. You just open Burp, and then you surf on the page running Burp. And so let's take a look at that. I'm not using it anymore this semester, but I used to use this Hackathon page, which is a deliberately vulnerable imitation of Amazon. And I've got, let's see, I go back to proxy, clear this old stuff. Oops. Yes. All right. So here's Burp, and someplace is the browser that comes with Burp, and here it is. Let me just make a new window. All right. And so let's go to Hackathon. There it is. All right. So this page opens, which is an imitation of Amazon with many vulnerabilities. And over here you see all the requests that were used to make that page. And you can also go to where is it? Someplace there's the map. Let me take a look at my picture. Target sitemap. There we go. I never use it in practice, but you can observe the data here. Target sitemap. And then you see all the things that have been seen here. Here's Hackathon. All right. And let's see if I can clear this old stuff. Let's see if I can delete Hackathon. Delete host. There we go. See what this does. Yeah, delete the item. All right, now, if I go back to Hackathon and refresh that page, I think it's here. There we go. Refresh the page. There it comes back. Okay, so here's what we have. We've seen various things on Hackathon, like the cart and the category. And in user, there's login, but there's nothing there. There's login, password, and register is all I have seen at user. Now, if I log in, I will see more, of course. I can sign in, and I've made an account. And sign in. And now that I've done that, you see there is now more information here. There's my username and password. And now there are 5 items in the user container. And if I look in the cart, there's nothing in there. But if I go back home and I put an item in the cart, then you'll see it's now here in the cart. So you can watch it. You can surf the page and then build up the map here of all the pages that way. And that way you get to use human intelligence to do it. Yeah, Juice Shop. Yeah. Juice Shop is another one people like. I think it might even be more modern than Hackathon. All right. Anyway, let's try some Cahoots, which I should have. Let's open them up here. Yeah, the streaming does slow down my machine, but it's not too bad. The Hackathon I'm using is this one here. But you can download them. They're ROWASP projects. So if you want to use my open one, there it is. And if somebody else put up the Juice Shop one. Good. All right. I made a running version you can play with, and I used to have students hack into it in this class, but now we're using the Web Security Academy projects, which are better. Here it comes. And this is, I think, chapter 4. It is chapter 4, all right? So this is it right there. All right, 21. I'll see if any more appear. All right, that's apparently it. All right, so what tool will find every page? That's what the idea of a spider is. They're not perfect, but that's the idea. All right. All right, what part has validation rules? Yep, that's forms, of course, where it can tell what the data should look like. All right, which website feature is not a problem for a spider? All right, and that's the point why you use them, because even if you have a lot of pages, the spider will dig through them all. All right, what's the risk when spidering while authenticated as administrator? Yep, you can do something bad like delete the website. All right. And how do you use Burp to examine HTTPS requests? All right, the right answer is add the certificate to the browser. And I'm not sure I talked about this before, so let me just mention it right now. If you go here, my Hackathon site is not secure, but my home page is. So if you go there, samsclass.info, this is an HTTPS page, but notice it's got a slash through the HTTPS. And the reason it does is if you go here and look at the certificate is not valid. And the reason is because the certificate was issued by Portswigger, the makers of Burp. So what Burp does is when you go to a secure page, it automatically generates a fake certificate from an untrusted source, and it sends that invalid certificate to your browser. So here's samsclass.info. It makes an HTTPS request, but it sends it a fake certificate, so your browser will warn you. Now, the browser, built into Burp, has been told to trust that certificate, but it's a user-specified trust, and so I think that's why it puts that warning there. I'm not sure. But anyway, that's what Burp does. Burp does a man-in-the-middle attack with a fake certificate, and therefore, a normal browser will warn the user. However, studies have shown most users have no idea what that warning means, and they'll just click through it. Anyway, that's what you do. And what Burp feature will stop all the traffic? That's intercept, and I see a lot of people know that. That's why the first thing you have to do is turn off intercept almost every time you start Burp. All right, I know who those people are. Oh, yeah, there are a lot of smart cookies in this class. I think there are. Good. All right. So user-directed spidering, like what I was doing, where you click around manually on a site. Then you can, of course, enter valid data, log in, avoid clicking dangerous links, and so on. All right. Chrome developer tools are another way to see every request and every response. You don't need a proxy. And you often... So you can view it here, just turn on developer tools, and it will show you a timeline saying how many milliseconds it took to load each element. And that's often useful if your page is loading slowly. You can try to figure out which part of your page is slowing it down. And you can see each request and response here. And you can open a JavaScript console and see error messages from the JavaScript running on a page. And you can inspect elements and modify them, and that will modify the page. So it's really very powerful, the developer tools inside the browser. All right, and there's another chart of how long it took to load all the different components. So there might be hidden content on a site of various kinds, just content that's hard to find, or maybe even content that's deliberately hiding. Very commonly, people leave old pages up on a site in the process of development and don't take them down. I've found sites where they left things in like old login pages and such, which you could log in easily and such. So backup copies and things like that. Often lots of goodies are left over on the server. Is F12 illegal yet? Well, I don't know. This is, I think, a Missouri governor brought that up, but it is actually important. If you were to examine the source code of somebody else's website and see something like a vulnerability, you could arguably have broken the law. The Computer Fraud and Abuse Act says if you learn something from a website that you're not authorized to know, you have committed a crime. So, however, if you have a good lawyer and you're not insane, and you let your lawyer defend you in court, you could probably win. But technically, that governor that said this guy pressed F12 and he found like confidential data on a website, that would appear to be, on the surface of it, a violation of the Computer Fraud and Abuse Act. He will now have to defend it, and his lawyer will probably claim that that was legitimate use of the site, but that the law does not make it clear what you can do. The apparent surface of the law says if you do anything on a website that the designer of the website did not intend for you to do, you're breaking the Computer Fraud and Abuse Act. And it doesn't even have to be breaking written terms of service. It can be breaking whatever they imagine the terms of service to be. However, you get to defend yourself with a lawyer, and you need to. That's why you need a lawyer in this business, because a lot of obviously legitimate research is somewhat illegal. And by the way, that's true of everything in America. If whatever you do in America, you run some risk of a lawsuit. Like the college gets sued all the time. I mean, you put up free classes for people, and then they sue you because the sidewalk has cracks in it or something. You know, everybody has to have a lawyer in America, and you just have to accept some legal risk to do anything. There is no such thing as being 100% legal. You have some degree of legal risk all the time, just like all the other risks. Anyway, you can have backups, new functionality for testing. You might have default things. This used to be a big problem with Microsoft Web Server. It would come with a bunch of default scripts to show off features that weren't secure, and if you didn't know enough to delete them, it would expose things. You might have configuration files, source files. If you can get to source code, an awful lot of people hard code passwords and credentials and API keys in source code. And sometimes log files contain cookies and other things that shouldn't be in there. And then, of course, there are brute force techniques. So if you're finding your user-directed spidering finds this stuff, login, forgot password, then EIS auth login, EIS home, EIS pub. So now you know everything seems to start with EIS. And here you can just try all the common words about abstract academics. There's quite a few tools that will do this, that will just have a list of common website words and try them all to find other pages. Burp has a brute forcer, which you have to feed in the payload, but it's very slow. A better tool is Derby. Derby is in Kali Linux, and it will just automatically try a long list of common words. And this is often the first step when CTFs and when trying to do attacks on websites, is just run this to find the pages that you can try attacking. All right, let's try another Kahoot. 4A is done, we're up to 4B. Now, I remember when I found a bunch of medical data just wide open sitting on a server, and they accused me of hacking the server. And when I called my lawyer, he said, well, technically you did. I just Googled and found some data on a server. And he said, that technically violates the CFAA. I felt abused. There was no password or anything. All right. Let's see how this looks. All right, so what tool will show you the timing of the components loading? And I see someone say they have no responsibility. They might also have responsibility to protect the data, and I think they did for HIPAA compliance, but that does not make it legal for me to find it. Technically, we were both wrong in the letter of the law. In practice, a competent lawyer can defend you. This is why you have human juries and human lawyers, because Just robotically applying the letter of the law is often not really enough to achieve what we would regard as justice. Anyway, developer tools will let you see the timing. All right, which tool is ineffective in its free version? Yeah, and that's ECC, you're quite correct. Just leaving your private data blowing around openly is a failure of due diligence and of due care, yes. So they did have to disclose this as a breach, which they then blamed on me. I felt abused. All right. Burp's brute forcer is very slow. All right. All right. Which tool will show HTTPS as easily as HTTP ones? All right, I'm going to have to modify this one. It used to be harder to do in Burp. Now that Burp includes a built-in browser, it's much easier. You used to have to configure your browser to trust Burp, and that's why I thought this was harder. And Chrome Developer Tools is a better answer. But now Burp is a pretty good answer, so I'll modify this question. This happens. This is why these things are extra credit. There are often defects in these questions. Anyway, all right, so how do you find all of the hidden content on a website? Yes, Burp built-in is Chromium. Yeah. All right, there's no sure way, certainly none of these. One way you might think is best is to hack into the server and get root and then dump all the files on the server. But modern websites build content from many servers and databases. It's so complicated these days, I don't think you could ever be sure you found it all. All right, that's Judy, I reckon. Well, it could be Jordan. Unfortunately, two people use the same initials and I can't tell. I'm guessing it's probably Jordan. I haven't seen Judy in the chat, and I am seeing Jordan in the chat. I'll go with Jordan. Yep. The others have some real name information there. All right. So, all right, it's 40 after. We can do some more. Let's go back to the slides. All right, so you can look for patterns in the content. Like here, like I say, there's all subdirectories start with a capital letter. So if she forgot password, try all reset password, update password, add password, and so on. Just deducing how they seem to name their objects. They might use numbers or dates. There's include files, including JavaScript and CSS and such. You should take a look at them. Comments may include more clues for things to look for, and Java applets and ActiveX control. If anybody's using those, they might have more information. Temporary files are often created. Here's a popular one. A DS store file is a directory index created by a Mac. Since I use a Mac and upload things to the web, I often get these files in there. There's files created when a file is edited. There's temp files created by Microsoft Office and many other documents, and they often are not really cleaned up like they should be. So all those things would have useful information. Burp Pro has a content discovery that will do what dir-b does. It will try to find common names It'll dynamically generate word lists and extrapolate them, do all these good things for you, which is why you pay a few $100 for Burp Pro, or you use the 90-day free trial of Burp Pro, which you can do. I'm using just the free version for everything. By the way, if you know a little bit of Python, you don't really need Burp at all. Burp is just a GUI for some Python scripts. But anyway, Skipfish was one that Google put out for a while. I think they quit updating it, unfortunately, but it was really powerful at crawling websites, as you might imagine. It was a vulnerability scanner, but the main thing I noticed is it would really spider a website like crazy, because obviously that is something that Google has put a lot of effort into. So you can go to public information like the Wayback Machine, forums, search engines, automatically cached copies of files. All those may have public information available. Google Advanced Search is quite valuable. You can specify a site colon, and domain name, and then it'll only look on that page. And in that site for things, you can look for all the pages that contain login. So you'll find all the pages that contain the word login. Here you'll find all the pages that link to this target, and here you'll find all the ones related to this target. So these are some of the many Google Advanced Search techniques you can use to find things from the Google Index. Would Google Advanced Search work on old sites? Yes, I think it'll work on anything you find in Google. I think it won't work on sites that have been totally taken down if they're gone. Then you'd have to go to the Wayback Machine. By expression login, does that mean the text login? Yes, that's what this means. This means the word login just appears on the page. Now you could also do in URL login, and then it would have to have that in the URL at the top of the page. That would be another way to... archive.org is one of them. Yep. And mydiary.doc, I don't know about that one. All right, so some web servers let you see raw source code. It's a fairly common error present in various versions of web servers, and you might find scripts with vulnerabilities. There are special web scanners, one called Nikto and one called Wikto, which is just the Windows version of the same thing. This is a very fast, very superficial scanner that just looks for about 20 common vulnerabilities. It's not very thorough at all, but it's very easy, and sometimes it finds good things. I ran it on my hackathon, and it always finds some really boring things. I never really found anything good using Nikto, but it is something people recommend. All right, then there's functional paths, where you would go to this page, and then there would be parameters that determine what you'll see. So every page has the same URL, and parameters are what determines it. In that case, it's very different than the kind of stuff that a spider would explore. So you have to do it like this. You mapping the past. There's login, there's home, then there's transfer funds, bill payment, and log out. So you can make a map of all the states of the thing and where it moves. Yeah, Nikto seems to never leave Kali, and there's many good alternatives. Yeah, I don't know. Yeah, I haven't got much good out of Nikto. If you got better suggestions, put them in the chat. I'd like to see. Nessus is, of course, good, although it's not particularly oriented towards web vuln scanning. Anyway, you can try adding debug equals true. Are there tools that create this map of paths? Not that I know of. Maybe Burp Pro, from what it said, but I'm not sure. Yeah, it's a good question. I'm not aware of a tool that does that, but I don't have a lot of experience with that sort of thing. So Burp Intruder can try adding a bunch of parameters to this. And so when you analyze it, look for the core functionality. Now, one thing that's important is you will usually find stupid mistakes made in the unimportant parts of an app that aren't used very much. If it's right in the main login and the main shopping part, they probably would have caught the error. You're more likely to find ridiculous mistakes in some corner that has just been neglected, like the password reset, or the login with use email and password when they really expect everybody to log in with Facebook, something like that. So these sort of things, you then look at how they handle authentication and maintain the session state and see if there's a flaw there. User registration, password change, and account recovery are, of course, high-value targets, because if you find anything wrong there, then you'll be able to get into other people's accounts by triggering a password reset or something. There have been a lot of bug bounties paid out for that. I think Facebook had this problem where you could, when it sent you a password reset, there was a random number, but it was not a random number. It was a number you could find by looking at somebody's Facebook page. You'd find it somewhere in the URL of images or something. So you could guess what the password reset link would be and change other people's passwords and get in their account. They paid somebody a bug bounty for that. Any place that takes user input, the query string, post data, cookies, then in principle you might be able to inject special characters or unexpected data. And all these client-side technologies like forms, and there's these thick client things that have pretty much gone in the way of the dodo bird, like Flash and applets and ActiveX controls. You'll only find those in old sites, but cookies are still around. And all those are ways data comes in, and if it's not properly sanitized and on the server, you can inject something. And on the server side, you've got the way it interacts with databases. That's what SQL injection does. Often the way it interacts with email systems can be exploited to send spam email and so on. So, all the URL string up to the query marker, every parameter, every cookie, all the headers, all these are ways that data came from your browser and went to the server, and they could be attack vectors. That's why the attack surface of a web app is very large, which is why this course in this book and this tool exists. It is so common that there's a vulnerability on your website. And if there's not one today, your developers will add a bunch of new features by next month, and there probably will be one. Then there's RESTful URLs, where you take parameters and put them in here as if they were folder names. This is bizarre, but we're getting better. Yes, well, a lot of the big mistakes of the past have been fixed, but we keep inventing new technology. So I don't think it's as simple as whether we're getting better or not. On top of that, the attackers keep getting smarter and developing better tools. So I think it's just like any other form of crime. There's a bunch of criminals. Sometimes they succeed. There's a bunch of good guys trying to stop them, and there's just an endless battle, like the cops and the robbers. Yep, there's so much stuff on websites. Yep. Microservices. Yep, there you go. You got. So it's the eternal battle. Everybody wants new features fast, so they rush them out, and securing them would often take too long. So a lot of them are rushed out too fast, and they're insecure. So it's a natural effect of a free market, I suppose. Yeah, so many tools and libraries. A bunch of people trying to secure stuff, and a bunch of attackers thinking of more and more clever ways to attack it. That's why it's an entertaining field. How can Brave legally post website content without inserting the ads? Well, I don't think it's illegal to filter out the ads. It's my browser, it's my computer. I should be allowed to tune into a channel and see only what I want to. As far as I know, I didn't sign a contract with, say, Google to promise to view their ads. I don't think I did. It's a good question, though. An interesting issue. There's a thing I mentioned before, 12ft.io. You put in front of a URL to break the paywall, and within a week, everybody had updated their sites to stop that from happening. Anyway, so here's request parameters. So if you go to google.com q equals duck, that will search for duck. That's the normal way you send a request parameter up, but you could do it all these ways. You could have a foo equals bar, foo true equals bar. You could have a dollars instead of an ampersand there. You could use %3d for the equal sign and %26 for the ampersand. It could have the parameter looking like a directory or with a different character separating the name from the value. This is why it'll drive you nuts. There are many, many ways to move that data to the server, and they'll all work as long as you program your server code to look for it there. So it is quite a challenge for any kind of automated scanning product to decipher all these strange alternative ways of sending data up. Yes, exactly. And I see some comments there that are quite appropriate. A lot of people just casually have a reset your password function, and you have to think about that. That's an open door for people to get into other people's accounts if it's too easy. All right, that's what happened to Sarah Palin. Somebody got in her Yahoo email by just guessing the town in which she met her husband, which is the town where she grew up. And she was using her Yahoo email for official government business, so it was a bad thing. All right, so HTTP headers have got things like user agent, which can detect if you're using a cell phone, and they may be able to sneak attacks in there. Or changing user agent, you might see other information. A lot of people reveal more information to Google than they do to an unlogged in user. And you'll find other headers like xforwarded4, which is what you'll have if you have a load balancer. So it keeps track of which of the multiple servers it forwarded you to. And there are out-of-band channels. Usually data comes in an email from publishing with FTP uploads or WebDAV. IDS sniffs traffic and puts it somewhere like in log files. And all these things are possible attack vectors. Network traffic is processed by some kind of script and stored in some kind of file, and you might be able to exploit that. All right. So let's take a look at C. Yes. For C. All right. It looks like we got everybody. All right. So what file is created when you edit a file? The one with the -1 is created by some editors. All right, what system would put data sniffed from the network into a web app? All right, that's the IDS. Which header may expose private data from one website to another website? The referrer shows the URL of the page you came from, and if that page was unwise enough to put something sensitive in the URL, like a username or a password, that would be exposed to the other website. It's another reason not to put sensitive data in a URL. All right, which one is the vulnerability scanner on Windows? All right, and that's Wikto. Good. Now I see a question. Could IDS replace the job of a transparent proxy? Take it over the transparent proxy detector. Well, I'm not really sure about that. An IDS doesn't usually let you examine the data. So I'm thinking it doesn't really give you the functionality you'd want from a transparent proxy. HEMA. So I'm not sure I understand the question well enough to give an intelligent answer. And Kitty. I hope my grader can figure out who that is. We will see. All right. So let me stop this recording.